Despite their small size and simplicity, microorganisms like bacteria are capable of extremely complex tasks. They can infect and take over entire communities, adapt beyond many of our drugs, seek out food, and work together to accomplish tasks. Microorganisms even make most of Earth's oxygen. Most interestingly, microorganisms are constantly consuming, storing, and utilizing chemical and solar energy, allowing them to do things inanimate objects cannot. In the Malouk lab, we are trying to reproduce this behavior artificially by finding and designing new ways for nanomaterials to turn the energy we give them, like chemicals and ultrasound, into locomotion and useful work. For example, we can make nanoparticles that consume hydrogen peroxide to generate motion at the nanoscale. These artificial swimmers can even mimic bacteria in some ways by interacting with each other and traveling towards fuel sources over time. Lately, we've been working on powering motion using ultrasound. Put simply, we can make microscopic shells that trap air bubbles inside, where the bubble becomes our engine. Like bells or the strings of a guitar, the bubble is able to vibrate only at one note, or frequency, which in this case is in the ultrasound range. When the bubble absorbs this perfect frequency, it vibrates, creating a jet of fuel that pushes the swimmer forward. A magnetic metal coated on the shell allows us to control it with a magnet. This method is extremely biocompatible because it is generated by clinical-grade ultrasound and even outperforms biology, moving faster than any natural organism relative to its size. We can even gently pick up and move objects that were previously impossible to relocate without damaging, like cells. We hope to translate this technology into microbiology and clinical applications and dream of one day making true nanobots to improve human health and our daily lives. Thank you.